bathroom scale is compressed 1/16 inch when a 150-pound person stands on it. Assuming the scale behaves like a spring in Hooke's that obeys Hooke's law, how much does someone who compresses the scale 1/8 inch weigh? All right, so if it's going to be Hooke's law, we know that the force is going to equal some kind of constant multiplied by x, where x is going to be how far it compresses from its original state. Well, here it's going to compress 1/16 inch. So we're going to have k multiplied by 1/16. And that's going to equal the force, which is going to be 150. Since I know that weight is a force, that's what it's going to be. So in order to solve this, I'm going to multiply both sides by 16. So you end up getting k equals 2,400. Now, if you want to know the units of this, the units, pretty much we need pounds on this side. And this is going to equal something multiplied by inches. In order to get pounds, we need pounds per inch. So the unit of my constant here is going to be pounds per inch. So the force of this spring, no matter what, and since we're not going to change springs, is going to be 2,400 multiplied by x. Now, how much does somebody weigh when it compresses 1/8 inch? So that is going to be 1/8 inch is going to be this. 2,400. And we're going to multiply that by 1/8, which ends up being 300. And that's going to be 300 pounds. So that's how much somebody has to weigh in order to make this spring go down 1/8 of an inch. Now, the work done is going to be my force multiplied by my distance traveled. Well, since my force here is not constant, I can't just multiply it. So my work here done is going to be the integral going from 0 to 1/8 of f of x, and f of x in this case is going to be 2,400. And then dx is going to be my distance, and then this is going to be x, for 2,400x, and then dx, because it's a change in x. So if I want to solve this, I end up getting 2,400 multiplied by 1/2 x squared, evaluated from 0 to 1/8. So this is going to actually be 1,200 x squared, evaluated from 0 to 1/8, which ends up being 1,200 multiplied by 1/8 squared, and then minus this put in, which is just going to be 0. So we're going to erase that really quick. So all this is going to be 1,200 divided by 64, which ends up being 18.75, and this is going to be inch pounds, since our units were in inches the whole time.